Hello there! As you know from the previous parts of the course, we already have the first 3D model exported and ready. Let's integrate it into the scene as the main element of our game. Our approach will involve establishing the ship as an essential component within the main scene, ensuring that the ship's node remains consistently present in the scene tree. During the later phase of the project, we'll be adding the ship dynamically, which is definitely more flexible. Okay, so let's drag the exported ship file player GLB to the folder models. It's being imported, and there it is. Godot imported the model and extracted the texture as a standalone image. We will right-click the player GLB file and create this new inherited scene, and ship opened in Godot. And a root node player appeared in the scene panel. We'll right-click this node and select change type, and we will choose character body 3D. Character body 3D, here it is. This is a special class provided by the Godot engine, and it will help us handle the ship's movement and interactions. Also, you can see the ship's modules, body, wings, engine, etc. as child nodes of its root. As we know, we have a fixed camera, so we must ensure that the ship won't leave the screen. To achieve that, we will soon add the boundaries to the scene. However, the model won't interact with them until we add a collision shape, which is why we can see this exclamation mark here. So let's do it now. We will add collision shape 3D as another child node of the root. Right-click player, add child node, and collision shape 3D. This is it. Okay, and we will display its properties in the inspector. We need to assign a shape which is currently empty. Let's click it and select for now a simple sphere shape 3D, which could be roughly sufficient. As we can see, the shape is much smaller than the ship, so we need to enlarge it a bit. Let's click the shape here and increase the radius. Yeah, I think we can just round it to 4 meters. Yeah, that should be fine. Very well. So, we should be finished with the basic scene. Let's save it. Ctrl S and player TSCN. We will put it to the folder scenes. There we go. Now we need to attach a script. Let's click the root node player and click this icon to create a new script, player GD. As you can see, Godot automatically suggested a template for character body 3D basic movement. We will take advantage of that. Let's click create, and you can see that there is already a much bigger script than before because it contains the logic of moving the character body 3D. Let's get back to the 3D part of the main scene, and let's drag the newly created scene, player TSCN, as a child node. Okay, very well. What happens if we run the game? Yeah, the ship is here, but as you can see, it's falling because the default script includes gravity, which is not present in the space, so we'll get rid of it soon. Let's get back to the script and let's find what we can delete from here. We'll definitely increase the speed because it would be too slow. Let's make it 30, and let's get rid of jump velocity because the ship won't jump at all. And the gravity, okay. Now Godot will show some errors which we will easily get rid of. And yes, that should be okay. Let's run it again and use arrow keys to move it. The ship is moving. Perfect. And now, since we finally have a ship in the scene, we can add its statistical data to the debug overlay. Let's close it and get back to the debug GD script. No, we already have everything there. Now we need to create a new script of the main route. Let's click here and create the main GD. Okay. And we will have to add some parameters here. First thing, we need to work with the debug overlay node. So the easiest way is to just drag it here and hold the control key, which will create the variable declaration with the already annotation automatically, which is very helpful. We will do the same for the players node. Okay. And now the functionality is called when the node is first initialized, which is exactly what we need to pass the player's variable to the debug script. So we have the debug reference here, and the function init is created there, and we will send player. Okay, let's try it now. And it's here. As you can see, the position is changing, and which is most important thing, the y coordinate still remains 0. So we are working in the exact plane as intended. Very well. Maybe I could say a few words about the game logic we have in the script. Let me switch to the script. Okay, so you may wonder why Godot generated the function physics process instead of the standard process. Well, the reason is that character body 3D is a physical object that interacts with other objects in the scene, so it's more reliable to do all calculations in the method that is called independently on the current frame rate. Shortly said, process without the physics is called as frequently as possible, while physics process works with a fixed frame rate. Anyway, it's not an issue in our game, as the calculations we need in this method will be simple and fast. As for the rest, input cat vector takes the input from assigned keys, which are the arrow keys by default, and we'll change it soon. Then we take the final value to calculate the ship's direction and velocity, which is used in the function move and slide, provided by Godot, to do the actual movement of the object and slide it across collision shapes. To ensure smooth performance and monitor the scene's performance, we click back to the 3D editor. There is a nice trick to see the FPS and CPU, GPU time and other things in the scene even before the scene is used in the game. Let me show you. There are these 3 dots at the perspective label. We click it and we select view information and view frame time. And voila! Now we can observe everything directly in the editor, which is very useful. Let's run the game again, and we will move our ship to the edges to find out the coordinates of the possible boundaries. Yeah, as you can see, it's minus 60 almost, which is good. If we move to the other side, should be 60 positive. Yeah, and about the top, the coordinate Z coordinates looks like 30. Okay, let's make it 30 minus negative 30 and 30. Very well. Let's make a note that the boundaries are probably contained in these values. Minus 60, 60, negative 30, 30. Okay. So before we add boundaries, let's just address the thing with the game controls. As I mentioned, the default values are set to the arrow keys, but it's more usual in many games that WASD configuration is used. For that, we can go to Project Settings and to Input Map tab. Here, we will add our own mappings for these movement keys. Let's start with move up and add, then move left, move down, and move right. And now to assign them, let's click this plus sign. Move up is usually W. Okay. Move left A. Move down S. And move right D. Okay, we can close the dialog. And now we need to change these strings here. It would be move left. As you can see, Godot already noticed the changes and gives us a hint. Move. Which one is it? Right. Yeah. Okay. Move up and move down. Let's try it out. Start the game. And now I'm using WASD keys to move the ship, so it works. Okay, let's address the issue with boundaries. We will add a new child node to this main scene, node 3D, just to create a group of boundaries. So we will call it boundary. And now we need 4 invisible walls to limit the movement of the ship. We'll right-click the boundary, add a child node. This time it will be static body 3D, which is, I would say, the best type for this kind of object. And again, the static body needs a collision shape. So let's right-click. Before we do that, let's rename it to left wall and right-click this left wall, add child node, collision shape 3D, and we can leave the name as collision shape 3D. Let's open the 3D editor. We select left wall and move it to the left of the ship. Let's make it better visible. Now we know that our saved value of the coordinates was -60. So let's set it here in the transform property, and it should be x coordinate -60. Great, here it is. Now we need to set the collision shape of the wall. Let's change the shape to box shape 3D and click it, and let's adjust the size to form a wall. X can remain 1, Y would be, say, 20, and Z 100 to make it long enough. There it is, the first wall is there. Now we can repeat the same process to create 3 more walls, top, right and bottom. Let's proceed with the right wall, which we will easily make as a duplicate of the left wall. So I press Ctrl D, or I right click and duplicate here. Let's rename it to right wall. Okay, and we need to change the coordinates because it should be located on the other side of the viewport. So not -60, but 60. There we go. Great. Now let's right-click boundary again, create a new child node for the top wall, static body 3D again. We'll rename it to top wall and set the coordinates to what was that? Negative 30, right? Okay. Negative 30 for the Z. And we need to assign the collision shape 3D again. Make it a box shape 3D. Again, click it, and this time X would be, let's try 200. Yeah. Y 20 again, and Z could be 1. Very well. This is the top wall, and again we'll duplicate, Ctrl D to make the bottom wall. Okay, and the coordinates would be changed to positive 30. Okay, we have the boundaries. Let's try them out. Execute the game. And now when I move the ship down, cannot go further. It looks like it works. Up. Maybe it's not too accurate. We might want to fly a bit more to the top, or we can easily change it later. It's not a problem. The important thing is that the boundaries are working. So, we have the ship and we have the boundaries. Let me say a few words about materials. As I mentioned before, it is a good practice to share materials across the models, if possible, as it reduces the rendering overhead and the GPU memory consumption. In the book, I demonstrated two methods for adding shared materials to models in Godot. In this video, I will work with only one of them, but it's the more convenient one, as the external tool, Material Maker, does a lot of work for you. So, we opened Material Maker, and now we have two options. Either we can create a material from scratch, which is a very powerful way, but it requires some learning first, or, which is usually my case, there is a way to load an already created material from the website. So let's open File and Load Material from website. Here's the material repository, and let's find something metallic for the spaceship. Metal. Okay, this one looks pretty nice. Let's open it. It's already being generated in the preview and looks cool. So we can export it, but before we do, there is one more thing to verify. As you know, our game is 2.5D game and the models are pretty small, so it's not necessary to use a texture size that big, which would take too much space on the disk and so on. So let's reduce it to, for example, 512 by 512. That should be pretty sufficient. Okay, let's open File, Export Material, Godot, and we'll select Godot for Standard. Okay, and I will export the material as metallic. Save. Okay, we can close Material Maker now. And let's import this material to our project, to the folder materials. Let's find it here. And it's important to import not only the material definition file, this file trace, but also the textures that have been exported from the Material Maker. So let's select all of these files and move them to the material folder. And there it is. If we click Material Trace, material can be observed here and looks pretty metallic. So let's add it to something. We will switch to the player scene and let's select wings, for example. To assign a material, let's open Surface Material Override, Property, and drag Material Trace here. Wow, it looks really shiny. Let's check it out in the game. Yeah, you can see how the reflection changes as the ship moves, because there are some visual distortion with our camera and the directional light is just reflected in with different angles. Okay, so yeah, you can use the very same way to create or export as many material as you want, and that's exactly what we'll be doing in the later phases of the game creation. Let's switch to writing some code for a change. As the game becomes more intricate and a lot of new code is added, it becomes essential to access specific game functionality from any part of the project. Yeah, I'm talking about the autoload scripts that we already created, one of them, the utils GD. And now we'll proceed with creation of another one to accommodate this growing complexity. So let's add a new script, right-click autoload, create new script, and let's name it Game Manager, as it will contain a lot of game-specific code that is required to be accessed from various parts of the project. Now we need to make this class truly autoload. So project settings, autoload, and let's find it here in the path, autoload, game manager. Game manager name is okay. Let's click add, and it's here. Good. Now we will open the game manager GD script here and delete all unnecessary code. Okay, let's add this. Var boundary equals, let's create a dictionary structure, which is called a map in many other languages. It works just the same, key value, 0, left, right, okay, top, and bottom. Okay, we'll use this variable to store the detected boundary values, which will be very useful when we, for example, want to verify that the game object is still within the boundaries, because if it's not, we can safely remove it from the node tree and save some memory space. And let's add some functions. Func set boundary. Yeah, nothing unusual here. We're just assigning the initial values to the boundary structure. Okay. And now the function that verifies that we are still within the boundary. Func is in boundary. What is? And if we want to add some tolerance, add margin true. Okay, this statement means that we want to add a default value to this parameter, so if it's omitted when the method is called, it will be automatically assigned to true. Yeah, I forgot to declare one more variable here. Boundary margin is 10 as a default value. Okay. If do the margin, else 0. Yeah, what is this? This is a ternary operation. It is the same as some other languages use a question mark and a colon, so which means if add margin is set to true, let's use this value. If not, let's use 0. Okay, and we can return the result. Position x boundary left minus margin, and I think I'll copy paste this to make it faster. less than boundary right plus margin int node global position z, as we are working at the xz plane, so there is no y coordinate is always 0, as we know. Boundary top minus margin and no, less than boundary bottom plus margin. Okay, this should be all for Game Manager GD. Let's save it, Ctrl S, and now we will use this function in the main script here, main GD, and we'll add it to already. Let's make it the first one because it's usually required at the start, so we can call it Game Manager. Set boundary, it's already here in the code completion because we say the function, and now we need to add the boundary values from the node tree. So we will just find left wall and drag it here, and yes, and I think it should be in quotes, which is safer, I guess, or maybe not. Position X, then we do the same for the right wall. Position X, and the top wall, let's try it without quotes, it should work as well because there are no spaces in the name. Position Z in the bottom wall, position Z. Okay, no errors so far, and we just make sure that the game still starts. No changes should be there at all. Okay. One more thing, it's likely that we will probably use the boundary object in more than one scene, so it would be helpful to have it separated into a standalone scene that can be easily included in other scenes. To do that, we will right-click the boundary node and select Save Branch as Scene. And now we will just choose boundary JSON. This is a good name. Let's put it to the scenes folder and save. And you can see the node was automatically converted to a node that contains the boundary scene. If we click it, it would open just the scene as it is. Good. Our game is not too visually appealing at the moment because it just shows something gray in the background. It doesn't even resemble the universe, so let's fix it. Many games utilize a sky environment, typically through a skybox, to create a realistic sky backdrop. We could employ this approach and attach a starfill texture to the skybox for the effect. However, since our objective is to simulate a continuous top-down movement, achieving that solely through a starfill texture would require adjusting several parameters, potentially even coding a custom sky shader. Instead, we can leverage the advantages offered by our fixed camera and generate a dynamic start field programmatically. Let's do it. So let's add a new child node to the main root, and this child node should be of type world environment. Okay. In inspector, here. In inspector, let's click environment and select new environment. Click it again to open the panel of properties. For now, we'll only set the background color of the scene. Let's find the property mode and select custom color. It is black, which is exactly what we wanted. If we click here, we can see the background is pretty black. Okay, as we are in the space. Run the project, and everything should be black here, which is great. Now, let's right-click the folder Scenes and create a new scene, which would extend Node 3D, as we're going to create a 3D object that works as a star. And let's call it small star. Okay. Okay. And we will add a child node to the root node of this scene, and what we need is mesh instance 3D. There it is. Open it in the inspector and click mesh, and let's add a sphere mesh because most of the stars are spherical. Let's click it again, and we will add a simple material. But first we will specify some basic parameters of the star. If in our implementation we'll incorporate numerous stars into the scene, and since these stars will be visible from a distance, we don't require an excessive amount of detail in their appearance. The focus will be on creating a visually pleasing effect rather than some intricate individual star designs. So we can optimize the level of detail, which can ensure smooth performance even if there are many stars in the scene. So let's set these parameters. Radius would be 1, height 1, radial segments 16 could be okay. Rings, let's make it 1, and is a hemisphere set to on, which resulted in a cone, as you can see, but it still resembles a sphere viewed from the top, so it is perfectly okay for our case. Now let's click Material and create new standard material 3D. We click it again and change just the albedo color to white, which is already set by default, so we don't need to do it. Now let's assign a new script to this scene. Let's click here and create small star GD. And what we need here, we need to get rid of the ready function and get rid of the process function as well, because we'll be controlling the star field from game manager script. Let's add a variable vertical speed. The reason is that we don't want all the stars to move in the same speed. It wouldn't look too cool. So every star can be assigned a random speed to give us a better, I would say, depth perception. Function init and coordinates of the star and its size. Okay. And now we want to move the star to the required position, which is done by the function translate that accepts the parameter vector3, x, y, z, of course. Now scale, because the stars would be of a different size. Again, it's a vector3, and we want to scale it in all dimensions the same size, okay. So the cone remains the cone. And finally, vertical speed would be assigned to plus y. Yeah, that's why we need the y coordinate, because the farther the star is from the camera, the slower speed it would employ, I suppose. Okay, this is okay, and now we want to control the stars, so we will add them to a group, so we can easily look up for our for sorry, we can easily find all active nodes of the same group by standard functions of the Godot engine. So let's give it a name, small star, add. Good. Now the star scene is prepared, but of course we won't add these stars manually to the main scene as we did with the player's ship or the debug overlay. The reason is that, of course, we intend to incorporate an increasing number of stars over time, so we need to apply a dynamic approach. To accomplish that, we will handle scenes directly in the code, providing greater flexibility and control. So we open Game Manager and let's add some more code here. First of all, we will add the star scene. Nope, sorry. There must be another way, and I know exactly what. This one. Okay. And ready for small star scene. Okay, so what we just did, we created a new variable that is declared when the node is ready, and it loads the star scene into the game manager, so it should be ready each time we want to add a new star. Now we need to add functions to actually spawn stars and move them. Spawn star, and we need a root node so the game knows where to add this star. It must be added as a child node of some scene, and let's say we will create 40 stars for now. Later we can make it random or fluctuating, it's not a problem, but the result is just the same for the testing purposes. And we will spawn a single star 40 times. Okay, the second parameter, I will explain it just in a while, because we need to implement the function spawn star first. Yeah, basically it means if the star should be created on the top of the viewport, or if we want to just replace a previously removed star that left the viewport. Let me show you in the code. So yeah, we create a new instance of this imported star scene. So small star scene, and we call the function instantiate on that. Okay, and now as we created in the script, small star gd, yeah, function init, so we can call it from here, star init, and now we will add some random values. Let's start with the x coordinates, randf range, which gives us a range between set boundaries, a random number, so it would be boundary left and boundary right, as we want to have them within the viewport. Then y coordinates is just the size and speed of the star, so again rand f range, so the number would be float, not integer, minus 20 and 20. No, sorry, negative 50. These numbers are actually a result of my previous experiments, so don't take them as something I just created here on the fly. It should ensure that the visual experience would be okay. And now Let's set the z coordinate, and we'll use a ternary operator again. Boundary top minus boundary margin if on top, else rand f range too many brackets, boundary top, boundary bottom. Yeah, and the final variable was size, I suppose, so let's give it again a random number from 0.02 to 0.2. Okay, and we need to add this newly created scene to the root node. Otherwise it wouldn't be visible at all. Add child star. Nice. So we created stars, but they are not moving yet, of course. We need another function to move the background process. Background, again, we need to refer to the root node, and we need the delta value from the main script, so the movement would be smooth regardless of the current frames per second rate. And let's do it for all stars we have. So now for small star in, and this is why we created the group small star. Get tree, get nodes in group small star. And for this we will implement the following code. Small star global position z is increased by small star vertical speed multiplied by delta delta. Okay. And now we need to check if the star already reached the bottom boundary, because if it does, we need to remove it. Otherwise, the number of star instances would grow indefinitely, resulting in the memory leak. So let's var z equals small star position z, and now if z is greater than boundary bottom plus boundary margin, let's get rid of the star. Small star Q3. This is important because if we don't do it with this Q3 and just remove it instantly, Godot could return an error if it happens before the current frame finishes. So this ensures that it would be synchronized with the frame rate. And since we removed the star, we want to spawn a new star at the top, so the total number of stars would be consistent. Spawn star, root node, and now it's false because now it's true, because we definitely want to create a new star on the top. That should be it. And let's call it from the main script. In the main script, we need to spawn the stars, so we add it here, game manager, spawn stars, and the parameter is root node, which is this scene. So we will use self standard pointer to the current scene. And in the process function, we want to move the star field. Game manager, process background, again pointer to the current scene, self, and delta value. Okay, and last thing, we have the debug layer, and we want to observe and monitor the number of stars to make sure that everything is being created and deleted as we expect. So we will add a new variable here, small star count, which is 0 at the start, and in the function process we want to calculate small stars count as, again, we take all the nodes of the predefined group for the small star, get nodes in group, and small star, and now just the number, just the size of this array. And we need to add it to the text property. So let's do it just like before, and small stars plus str small star count and end of the line. Very well. Let's check it out. Yeah, can you see it? Star field. And take a look at the debug overlay. Number of star is consistent. It's a little bit fluctuating because there could be a small delay between destroying a star and creating a new one. But the important part is that it doesn't grow. So we are correctly destroying the star objects, and the total number is always 40. Okay, I think that should be enough for this video, and in the next one we will start adding enemies to endanger our player's ship. See you next time.